Okay, just going to go through the rest of 11.5 integration by substitutions. This is just part 2. A couple more examples. So this first one I was to prove that question. I'm going to prove that 1 over the square root of 1 minus x squared, when that's integrated, it goes to arc sine x plus c, or inverse sine x plus c. And again, this is a really difficult question, but you can use a substitution. Now, let's think about which substitution you could potentially use. So some people might think, well, what about if you tried u is equal to 1 minus x squared, or replaced everything inside the square root with a u, and then have 1 over root u and hope to see if that works. And unfortunately, that's not going to give you the answer in this question. That wouldn't be a good substitution. So there must be another way to do this. Now, the clue is obviously in what the answer is giving you. Somehow this ends up something to do with trig. And you might recognize one of the trig identities, something 1 minus something squared. And that's the clue you're going to look for. So you've got something to do with sine, you've got something to do with 1 minus x squared. And yeah, the clue is let x equals sine u in this case. Use that substitution, replace every single x with the sine u. Let's see what does happen. So I'll call that integral I. So I is equal to integrate 1 over the square root of 1 minus x squared, but I'm replacing the letter x with sine. So sine squared u dx. Obviously need to change this dx. So if I take the original substitution, I differentiate, do dx by du. What does sine u differentiate to? I'll go to cos u, and then I want to make dx the subject. So dx would be cos u du. Okay, let's do that. So integrate 1 over, I'm going to leave that as it is for now, but replace this dx with cos u du. Now, would this simplify at all? Because the whole purpose of a substitution is something will simplify, and 1 minus sine squared you should know is cos squared. So square root of cos squared u. And then 1 over square root of cos squared u, well, square root a square, it disappears, so that's 1 over cos u times cos u du. And there it is, there's the simplification. Cos u cancels with cos u, and you're only integrating 1 with respect to u. And that is the easiest integration of them all. So just integrating 1 with respect to u. So that really complicated thing was simplified to just integrating 1 with respect to u, which goes to u plus c. But that isn't the answer to this question because it's a proof. Or if you made u the subject in that original substitution, so if you made u the subject, you'd have to do inverse sine, which is arc sine x equals u, and replace that in there. You get arc sine x plus c, end of proof. There's the proof square. Okay, one more type of example. Some definite integration. So you want to integrate this complicated looking function using substitution. So So are there any suggestions of what substitution to pick? Now, I know it didn't work last time, but it might work this time. So I'm just going to pick the thing inside the square root to be the letter u and see what happens. So let's let u equal 1 plus sine x. So in other words, if I call that I, we've got I is equal to integrate 0 to pi by 2 cos x square root of u dx. And now do some substitutions. So cos x, that's not easily going to be substituted, is it? If I can't really make cos x the subject, so I'm going to leave that as it is. And I'm just going to do du by dx, which would go to cos x. And if you make dx the subject, you'd have 1 over cos x du. If you replace that in there, you get integrate between 0 and pi by 2 cos x root u times 1 over cos x du. This looks promising. Cos x's disappear, and then you are just integrating between 0 and pi by 2 of u to the power of a half du. And that looks like it'll give you the right answer. So let's keep going. Integrate between 0 and pi by 2. Add 1 to the power, add 1 to the power, divide by the new power, and that's between 0 and pi by 2. But this is where you're likely to make a mistake. In this initial integration, everything had x's, which meant the limits were actually x's. And at the moment, these limits are still x's. So I can't really do anything until the x's are back in there at the end. So this is equal to 1 divided by 3 over 2 is 2/3. I have to replace the letter u with 1 plus sine x. Put those back in to the power of 3 over 2. And that's between x is equal to 0 and x is equal to pi by 2. And now I can actually do the substitution of the limits. So if you remember how to do this, it is 2/3, 1 plus sine pi by 2 to the power of 3 over 2, subtract 2/3, 1 plus sine 0 to the power of 3 over 2, and then type that into your calculator. So 2/3 brackets 1 plus sine pi divided by 2. I'm in degree mode, switch to radians. Pi divided by 2 to the power of 3 over 2. Subtract 2/3 brackets 1 plus sine 0 to the power of 3 over 2. And then that should be it. So I get 1.22 to 3SF. And I can check my answer by writing that, using the fancy calculator, typing integral in, that very first one, which is cos x square root of 1 plus sine x dx between pi by 2 and can't type the 0 in, 0. Hopefully these will match up. Calculator still thinking. Yeah, 1.22, same as the answer I got. And that's pretty much integration by substitution. If you've got limits, you just got to remember you've got limits at the start in terms of x. So before you